Hello everyone and welcome to Netcracker. Today we are going to study data structure, and graphs and trees is one of the most important topic in data structure. So we will be discussing this today, and let me tell you that number of questions are asked every time in exams from graphs and trees. So it is really very important for you to study this thoroughly, because easy and basic questions are asked from these topics, but one needs to know the basics of graph theory and trees so that you can score well in your exams, right? So here I will just be discussing a few topics from graphs, and then at the end of this lecture I will be solving few questions, right? So let us begin. What do we mean by a graph? A graph consists of points or nodes connected to each other by way of lines called edges. Like here we can see that a graph has been represented with two components, E and V. E stands for the edges and V stands for the vertices, right? So this is how we represent a graph. So we know that number of nodes are there or points are there which are called as vertices, and the edges are the lines which connect them. Fine. So we have an undirected graph. This graph is the one in which the edge set contains unordered pair of vertices with no direction. It means that the vertices which appear in an undirected graph have no specific order, right? And the edges also do not have any directions given to them. But in directed graph, we can see that direction is specified to the edges. Here we have two examples of undirected and of directed graph. Here we can see that four nodes are connected to each other with the help of edges, but no direction is specified. And here in a directed graph, we can see that number of edges are there with some direction given to them, like they are moving from this point to this point. Fine. So we have two formulas with the help of which we can calculate the number of edges present in a directed graph and in an undirected graph. So how can we do that? Number of edges in undirected graph with no self loop. What do we mean by self loop? A self loop is formed when an edge starts from a vertex and it ends in the same vertex. Like here, this line is being drawn from this same vertex and it is ending on the same vertex. Fine. So in these types of graph, the number of edges is equal to n into n minus 1. Fine. This is how we calculate the number of edges in directed graph. So the number of edges in undirected graph is equal to n into n minus 1 divided by 2. This gives us the edges in an undirected graph. So let us study that what do we mean by a degree of a vertex. How can we calculate them? Degree actually means the number of edges incident on a vertex. So we have two types of degree: incoming degree and outgoing degree. Incoming degree means the number of edges which are coming towards a vertex, and outgoing means the number of lines which are moving from the vertex. So here we can see that V1 and V4, there are no incoming edges to these nodes. Therefore, the degree of V1 and V4 is 0, and in the case of V2 and V3, we can see that two edges are moving into the vertex V2, and similarly in V3. So therefore, the degree of V2 and V3 is 2. Now we have degree of graph. What do we mean by this? A degree of graph is indicated by the maximum degree of a vertex present in the graph becomes the degree of a graph. Like here, we can see that the maximum degree is 2, and that too of V2 and V3. So all over we can say that the degree of this graph is 2, right? And the pendant vertex is a vertex of degree 1, and those vertices are called as pendant vertex. Fine. So next we have the types of graphs. we have number of graphs in graph theory which we need to study, and null graph is one of them, which says a graph containing only isolated nodes are called as null graph. Like here you can see that v1, v2, v3 and v4, these are the four nodes present in a graph, but none of them are connected to each other, therefore they are isolated from each other. So this type of a graph is called as a null graph. And a complete graph is every vertex of a graph G is connected to every other vertex of that graph. Like here you can see that 1, 2, 3, 4, 5 vertices are given, and each vertex is connected to the other 4 vertices. Fine. In the similar way, here we have 4 vertices and each vertex is connected to the every other vertex. In similar way, we can see here and here. And to calculate the number of edges in a complete graph, that can be found out with the help of this formula, which is n into n minus 1 divided by 2, right? And then we have a regular graph. What do we mean by a regular graph? A graph which is having a same degree of every vertex makes a regular graph. Like degree of every vertex should be same. Like here in these 3 diagrams, we can see that over here each vertex has a degree 2, as each vertex is connected with 2 edges, therefore degree is 2 here. And even here each node is connected to 2 edges, therefore degree of each vertex is 2. Here each node is connected with 3 vertices, with 3 edges, therefore the degree is 3 for this regular graph. So these 3 are the example of a regular graph. Now just note these 3 points. Every null graph is a regular graph of degree 0, right? As we know that a null graph is the one which has an isolated node, so there is no edges present, therefore the degree of that node is going to become 0 as there is no edge. And a complete graph is a regular graph of degree n minus 1. What do we mean by this statement? Like here we can see that this was a complete graph and this is a regular graph. So complete graph, like here we can see that number of nodes in this complete graph are 4, right? So n is equal to 4 here, and here we have taken the same figure, but here this is a regular graph with degree 3. So this statement, let us read it again. A complete graph is a regular graph of degree n minus 1. Here n was 4 and degree can be calculated here by n minus 1, which is equal to 3. So this is a valid statement, so one needs to remember this. And if suppose you have been given a graph G with n vertices and n regular graph of degree r, then G has 1 divided by 2 r into n edges. To find out the number of edges in a graph where vertices is given and it is specified that it is a regular graph and degree of that graph is given as r. So the number of edges is going to become 1 divided by 2 r into n. Fine. So here are the number of graphs which we have studied today. 3 types of graphs: null graph, complete graph and a regular graph. So what you need to remember in this lecture is that these points, these formulas to find out the number of edges in these graphs. So in the next lecture I will be talking about few more graphs which are important. Fine. Till then, enjoy and keep studying. Have a good day. Thank you.